What if I told you that hidden inside your kitchen lies the key to unlocking metals, just like mining companies do, but using vinegar and some old coins? This isn't science fiction. This is kitchen chemistry. And in today's video, we're diving into the fascinating world of biomining, a technique used to extract metals from ores using bacteria, but reimagined for your home. You're about to witness real chemical transformations using nothing but everyday items. So get your gloves, safety glasses, and curiosity ready. Get ready, because we're about to transform your kitchen into a fun science lab. Segment 1. What is biomining? Alright, let's dive right into it and see what's going on. Biomining is a technique used by scientists and mining companies to extract valuable metals like copper, gold, or nickel using microorganisms, mostly bacteria. These tiny creatures live in extreme environments, acidic hot springs, volcanic vents, and feed on minerals in rocks. As they break down, they give off metals that we can easily collect. In a real lab or mining operation, you'd use strains like acidithiobacillus ferrooxidans or leptospirillum ferrooxidans. But in your kitchen, we'll simulate the same concept using acids, redox reactions, and household materials. We're all about breaking down metal with some cool chemistry, biomining style. You know. Segment 2. Kitchen chemistry setup. You're gonna need a few things for this, so let's dive in. A few copper coins. Older ones work best. White vinegar, your stand-in for weak acid. Table salt, a clear glass or plastic container. You might want to grab a steel nail or maybe an iron screw. Grab those protective gloves and goggles, folks. Safety is our top priority. Let's stay safe while having fun. We're going to recreate a reaction where copper is leached out into a solution, just like bacteria would do in nature. Segment 3. Experiment 1. Simulated copper, leaching. Ready to kick things off with a total classic that everyone knows and loves. Step 1. Pour about 100 milliliters of vinegar into your container. Step 2. Add a teaspoon of salt. Stir until it dissolves completely. What you've just made is a weak solution of acetic acid and sodium chloride. Together, they'll help dissolve the copper oxide on your coins. Step 3. Drop in the copper coins. Just hang tight for a few minutes and keep your eyes peeled. Okay, that blue or green tint, that's copper acetate, a compound formed when the acid reacts with the copper oxide layer. You've just witnessed a form of leaching, similar to what bacteria do in industrial biomining. Segment 4. What's happening chemically? Let's break down the reaction. Copper on the surface of the coins has oxidized over time, meaning it has reacted with oxygen in the air, forming copper oxide, which gives coins a dull brownish look. The vinegar, acetic acid, reacts with the copper oxide, forming copper acetate, which is soluble in water. Salt accelerates this reaction by acting as a chloride ion source, helping to strip the copper ions from the coin's surface more efficiently. This is the kitchen equivalent of what biomining bacteria do with their enzymes and acids. Only here, your bacteria are replaced by your pantry. Segment 5. Experiment 2. Displacement reaction, growing copper crystals. Now that we have copper ions in our solution, let's try something even cooler. We're going to extract metallic copper, just like mining companies recover it from solution. Grab an iron nail or a steel screw, give it a good wash, and dry it off. Simple, right? Step 2. Drop it into your blue-green copper solution. Now wait. Over the next few hours, you'll start to see orange or reddish crystals growing on the surface of the nail. That's pure copper. The reaction is a simple redox process. The more reactive metal, iron, gives up electrons to the copper ions, reducing them back to solid copper. You just mined copper in your kitchen. Segment 6, connecting to real biomining. What we did on a tiny scale, just a few milligrams, is done on a massive scale in mining. In countries like Chile and Australia, bacteria are used in huge bioreactors, or sprayed over heaps of crushed ore. Over weeks, they leach out copper and other metals. The resulting metal-rich solution is then processed to recover pure metals. It's cheap, it's sustainable, and it doesn't involve toxic chemicals like cyanide. Biomining is the future of eco-friendly resource extraction. And now, you've seen its principles in action, right from your kitchen. Segment 7, Kitchen Chemistry meets Sustainability. You might be wondering, why does this matter? Because chemistry, when understood at a basic level, empowers us. Want to teach kids science? Try this. Want to learn about how we mine rare earth elements for your phone? Biomining. Want to imagine future cities powered by green tech? It'll need metals mined in clean ways, like this. Even researchers are exploring bioleaching e-waste, using vinegar and bacteria to recover gold, silver, and copper from old electronics. What we just did is more than a fun trick. It's a glimpse of how nature-inspired chemistry is reshaping technology, industry, and education. Segment 8, Bonus Ideas to Try at Home. Still curious? Here are a few more home-based experiments that mimic biomining. Lemon juice and iron nails. Use lemon juice to clean metal oxides and observe tiny reactions. Hydrogen peroxide and copper wire. Add salt and watch copper ions form. Rust removal. Use vinegar to remove iron oxide and simulate iron mining. Just remember, do these safely, in a ventilated area, and don't mix chemicals unless you know what you're doing. Segment 9. Final thoughts. You don't need a lab coat or a billion-dollar mine to explore the wonders of chemistry. Sometimes all it takes is a kitchen, a question, and a little curiosity. So the next time you're holding a copper coin or pouring vinegar on your fries, remember, you're just a few steps away from biomining. Thanks for watching. Don't forget to like, subscribe, and share this with someone who loves science. And if you try this experiment at home, let us know how it went in the comments below. Until next time, stay curious and keep experimenting.